Hello students, let's read this question. What is the equation of the line graph below? One graph is given as we can see, and now we're gonna need to find which of these equations is the right answer. And that's what we're gonna do first. So we know that we have to find the equation for the line that is graphed. So we did circle and underline, and I'm gonna box the question. I need to find the equation for the line that is graphed. Remember the steps that we mentioned on question 1 and 3? Okay, but for those questions we said if a table is given. But here we don't have a table given. But can we generate a table from any given graph? Of course we can. So always one of these equations, remember, only one is gonna describe this graph. And this graph, we have a unique table of values. And that's what we're gonna do right now. We're gonna read some ordered pairs from the graph and generate a table. Okay, so I draw a table, guys, so we can record our values here. And remember that one value that is very, very important is the value of y when x equals 0. Remember on the x-axis, this horizontal line, we have the x coordinate, and then here up and down is our y values. Great, so what we're gonna do here, we're gonna identify when x equals 0, what's the value of y. Can you see this point here, guys? And since this line is going up, I know already that the rate of change is positive, which is called the slope too. So I'm gonna draw this point in green. So here now I'm gonna know that when x equals 0, y equals -2. You see that, guys? Great. Now I'm gonna check for when x equals 1, what's happening to the y. And I'm gonna come to this value when x equals 1. What's the value of y, guys? There's a 1 in here, right? Okay, so that's the value that we're gonna write. When x equals 1, up and down, the y equals 1. Great. And I'm gonna just highlight this so we can track better what we're doing. These values, we're reading those up and down, that's the y-axis. And the x values are the ones that we always read side to side. See that, guys? Great. So let's continue. I'm going to check the next value when x equals 2. And so I can read the point. The line needs to lie exactly on one of the corners of the coordinate plane. And then right here, I see that it's intersecting towards the y when the y equals 4. So you see this, guys? So when x equals 2, the value of y is a 4. So on the up and down line, we read a 4. And on the side to side line, we read a 2. Okay, so let's do the next one. What about when x equals 3? Okay, so that's what I'm gonna check right now. This is my 3. I go, you see, from the blue section, which is this number here, I keep going up till I touch the line. And seems like I need to stop on this corner right here. Now I'm gonna go towards the orange up and down line, which is my y-axis right here, and looks like this is a 7. So looks like when x equals 3, y equals 7. The 7 we read it on the up and down line. You see that, guys? Right here. When x equals 3, y reads 7. And that's the value that we got here. Okay, so remember, our first step in questions 1 and 3 was find the change on the x-axis and find how much is changing the values on the y-axis. So let's do it. So from 0 to 1, that's plus 1. From 1 to 2, that is plus 1. And from 2 to 3, plus 1. Great. Now I'm going to check how the numbers are changing on the y-axis. And remember, I always get started with my positives because they're more friendly. So from 1 to 4, that is plus 3. And from 4 to 7, that also is plus 3. Do I have to check the negative side? Yes, I do. So I'm going to do from negative 2 to positive 1. To go from negative 2 to positive 1, I'm going to think about the number line. So picture yourself on negative 2. How many units do you have to go to reach the 0? Great, that would be 2 units. Excellent. Now, from that 0 to reach the 1, how many more units do you have to move? That would be 1 unit. So in total, remember we said 2 before plus this one, the difference is plus 3. What we can tell here is that the rate of change is constant and that we can find the value of a slope. Okay, that was our first step. Or step number 2. I'm gonna write it here on the side. I'm gonna be using the equation y equal mx plus b. With this equation, this general equation of the line, we can go to a specific equation of one specific line, like this one. So what I'm gonna do is I'm gonna find this value of m right here. Because this line is going up, you see it's going from the bottom up. This is positive. This rate of change is positive because the line is increasing, it's going up. That value is the m. And how do we find that value? By dividing the change on the y-axis, that is divided by the change on the x-axis. And remember, the y-axis is what we color in orange, and the x-axis is what we color in blue. And I'm gonna find the change on y over the change on x, so we can find the value of the letter m, which is the rate of change. And I'm gonna say here this is m equals, so m equals the change on y is positive 3 over the change on the x-axis, which is always this one that you see here. I got this 3 from the orange side and I got this 1 from the blue side, from the x-axis. And this is our slope, m. And if I divide positive 3 divided by positive 1, that's going to give me positive 3. And that matches if I look visually at the line, because we saw that the line is going up. So that was already telling me that this value needed to be positive. And we got it positive. So that's great. So remember, finding the value of the slope was our second step. So this is really our second step, and I'm going to put that is our second step. So remember, anytime that we need to figure the equation of a line, step 1, check the change on the y-axis and check the change on the x-axis. From there, we find the value of m. That is just the change on the y-axis over the change on the x-axis. This little triangle, that's what it represents, that change. And then our step 3. Our step 3 is gonna be plug in, do substitution of those values in this general equation of a line. Always use this equation and it's gonna be our reference, so we can find the equation of a specific line, like this one that we have here. The y is our variable, so it stays like a variable, y equal m. M is the value that we just figured here, that is a positive 3. And I put it in green because that's how I identify it in here. When any number is in front of a variable, they are multiplying. We don't really write the multiplication, but it means they're multiplying. And then I'm gonna put my x in here, plus b. And remember, the value of the v is where this blue line crosses with this orange line, which is the y-axis. Or in other words, when on the blue line is 0, which is right here, this is the 0, then you go down and you see where here this green line crosses with the orange one. When we highlighted this pink point, well, that was a negative 2. And if we look at that in the table, it's right here. When 0, what the value of y is. Okay, so that is our answer. Now, normally we're not going to have one positive in front of a negative. Instead, we're just going to summarize. We're just going to rewrite it in simplest form. The 3, remember, is the slope, so I keep it green. I don't have to write the multiplication dot, but we know it's multiplication. Now, when we add a negative, really, we just keep it like this. So this is our answer. Do you see any answer that looks like this? 3x minus 2, letter A. Awesome, guys. Well, great job. Thank you.